The broadcast is now starting. All attendees are in listen-only mode.
Good morning, everybody. Thank you so much for joining us. This is Paul Benbow, and we'll be presenting the Chemical Risk Assessment and TSCA Reform in-house TSCA compliance from Chemwatch. A couple housekeeping notes before we get started. On your GoToMeeting control panel, you can toggle your screen back and forth with this little arrow that allow you to slide it back and forth so it doesn't obstruct your screen. And if you want to ask questions, there's a little question box down here. You can just simply ask questions there, and our staff will keep up with those, get back with you during the presentation, or if we get a lot of questions, we may have to get back with you after the presentation. But please do ask your questions there, and we will get back with you. Your speakers today, I'm Paul Benbow, Business Development Manager in Raleigh, North Carolina. And with me also is Tom Hassey. Tom is my fellow Business Development Manager in Detroit, Michigan. And our customer service team with us today, we have Nora Ballant, and she's out of our Nashville, Tennessee office, our support center. And Augusta Brinkley is also a technical support engineer for us, and she'll be doing a lot of the demonstrations with Nora. Nora will also be handling the question and answer, so we'll bring Nora back in at the end, and all of us will participate, but we'll actually answer your questions live. So that being said, so we're going to move along pretty quickly today. We got a full agenda. We want to make sure we cover everything and have a little time at the end. But today we're here to talk about how conducting your own risk assessments will help you comply with some of the new TSCA requirements and reduce the time to market for your products. You're going to chat a little bit about how the LSCA, the Latenberg Chemical Safety Act, will affect your chemical usage. The impact of TSCA reform on new and existing chemicals, what your business needs to do, and how our risk assessment tool, COBRA, and our expertise can help you by documenting the safety of your chemicals using scientific evidence and expertise, and basically helping you tell your chemical story to the EPA with accurate data. So just, 2 or 3 slides on Chemwatch. We've been around for 25 years. We started off authoring SDSs and basically grew from there. Found there was an ecosystem around authoring SDSs, managing chemicals. So we just kind of kept growing that. We're an international company based in Australia. We have 3 U.S. offices. Our customer ecosystem, large and small companies, that's the nice thing about a cloud-based application like we are, is we can scale to very large companies, or we can provide a great service for very small companies that don't need the IT footprint or the amount of usage. It gives us a very easy way to meter our product and what you need, make it very specific to your needs, and charging you proportionately. So very large companies can use our product effectively, very small companies can use our product effectively. That being said, in the top 20 Fortune 500 companies, 7 of those use our products. So, and industries, anybody with chemicals, oil and gas, automotive, electronics, mining, government, research, hospitals, universities, anybody with chemicals, managing chemicals, SDSs, they use our products. Part of our claim to fame is we just have lots and lots of data up on our cloud server. We have over 23 million vendor SDSs, fully searchable, indexed. We have over 300,000 Chemwatch Gold reauthored SDSs, and for those items we have over 450 data points that we can do really nice, powerful things, change languages, run regulatory information, labels. When we change an SDS from one country to another, which is a powerful feature of our Gold data, we automatically populate all 16 sections, and we can do this in 93 countries. So if you have an SDS for one country, you can switch it to an SDS for another country in about 5 mouse clicks. So whether you use our authoring tool to create your own, or you find a Gold data sheet that you want to provide to somebody else in another country, another language, all automatic, happens, like I said, in 4 or 5 mouse clicks. We have an integrated chemical regulatory database that makes us very unique in the market. Since we have our own chemical regulatory database of over 6,100 regulatory databases that we aggregate from 89 countries, California Prop 65, all that stuff's in there. So we have over 1 million substances that we've organized into 7,500 chemical families. But because our regulatory database is tightly integrated with our other data, we can tell you, you have a chemical, it's in this international location, and here might be the regulatory concerns with that chemical in that location. Or you're shipping a chemical and you need SDS that's going to go to that foreign country, be it China, Germany, France, Australia, wherever. We can tell you what that SDS should look like and populate all 16 sections, including section 15. So nice claim to fame. And our GHS classification database has over 250,000 substances classified. And we're still in the SDS authoring business. We author about 1,000 SDSs per month as a service. We use the same tool that our customers use, so we basically keep our tool very current, and we use it internally as well. One thing that makes Chemwatch a little different is we have a staff of about 170 chemical scientists. So because we keep track of regulatory data, we author SDSs in addition to providing software, and software as a service more specifically. We have chemists, toxologists, hygienists, regulatory experts, occupational safety and health experts, and physicians on staff. And so we basically keep our chemical data updated by our chemical scientists. Like I mentioned, we have about 93 countries that we keep all the regulatory information, SDS templates, labels, about anything you want to do for those 93 countries in 47 languages. We can transfer our documents back and forth between those countries. So if you're a company that needs that ability to work with an international presence, we have a dynamite product for you. And my last slide is basically, we're very modular. Everything is a .NET application, so we can, either turn a module on or off as you need it. If you need to come in through our API, maybe you have an existing system, you just want to consume our data or use our data to help you, that's very easily done because we're a .NET framework, and our API is very robust. And so it's very powerful to do that. So I'd like to go ahead and turn the presentation over to Mr. Tom Hassey. Tom?
Thanks, Paul. Thank you, everyone, for attending. What I'd like to do before I get started on talking about, let's say, some points on TSCA reform is to basically paraphrase how we're going to speak of it today. It's a rich piece of legislation. It affects many parts of how folks use chemicals. But what we want to talk about today is how does the legislation affect chemical management specific or relative to worker safety and hazards communication. So I'm going to jump on some key points within the legislation that will affect your company. First one, absolutely most important. Back in '76, when TSCA first came out, the burden was on the EPA to document chemical usage hazards. Now, the burden's been flipped to the company. The legislation affects all chemicals, both old and new. So that leads to what you need to understand, all the substances in your product lines. And you got to go back 10 years now. This is what the TSCA amendment states, is that the EPA identification of chemicals in active commerce is going to require companies to ID all chemicals that they manufacture or use 10 years prior to this legislation. So back to '06. Again, when you need to understand your chemical substances, when the EPA identifies a high priority chemical, it's going to ask you for all relative information about the chemical, and you got to be forthcoming. The reason is they're talking what I heard in a conference last week was 2 to 3 years to identify what is high or low priority, 3 to 4 years to do the evaluation. And so the key here is that you can provide relative information, accurate, up-to-date, scientific information on your chemicals and its uses. You're going to reduce the review time, and by doing that, you're going to reduce the time to market. The other is you got to stay informed of state level chemical regulatory activities. What happened at the last minute in this legislation, which happens in our system, is there was a preemptive language or clause entered at the last minute, allowing state regulatory behavior or actions to continue pursuant to that specific state's laws that were enacted before August 31st, 2003. Actually, the California legislators are the ones that pushed this through, and you know how you've had to work around Prop 65. It's very complicated. So what the preemption language has done, although it's very limited, it does give activist states lots of opportunities for workarounds. So the reform, let's break it out in existing versus new because it is different. Regarding existing, the EPA is now required by law to update their inventory of chemicals, or what's called inventory reset, because now the focus is going to be on what's on the chemicals that are in active commerce or usage right now. The next step is they're going to prioritize these chemicals, and they're going to be based on factors including environmental health, safety, results, and effects. You notice results and effects because these are chemicals that are existing. The EPA expects that there will be effect data collected against these substances. Their intended uses, exposures to workers, consumers, the general population, susceptible subpopulations, for instance, pregnant women, hazards and environmental impacts of these substances. Then they're going to prioritize them. The high priority may pose an unreasonable risk. Again, they're not sure yet because, again, this is just the early stage of splitting high versus low. The low, the chemical can stay in use, but it can be reprioritized basically at the high if there's new information available. Next step, risk assessments, risk evaluation, excuse me. And risk evaluation is really three pieces. The assessment is the key piece, and then the management around the risk, and then how you're going to communicate this management process or this process of usage. Risk evaluation will be mandatory for all high priority cases, and it's to determine if it poses an unreasonable risk. And it's going to be based on the prioritization factors, that were just listed above, and it's going to lean on or rely on the best available data. So, and then the end result will be a determination. If it meets the safety standard, go ahead and keep using it. If it doesn't, there's going to be restrictions. There may be regulations, or there may be specific labeling requirements, could ban it altogether, phase it out over time. For new chemicals, all users and suppliers must submit all available info to the EPA. You've got to provide EPA with all available info about its use, the chemical and its intended uses. So you need to look ahead a little bit, not just on current but future uses. EPA must conduct a risk-based review for all new chemicals. So it's going to review all available data on the market for this substance. Again, this is a new substance in the market. You may have more data than they do. If that's the case, it would behoove you to give it to the EPA. As we mentioned earlier, it will save time, and the way the legislation reads is the EPA will accept your data if it's deemed accurate, and we'll call it verifiable. Oh, sorry, Paul, can you go back? Sorry. I was catching my breath there. So after it does its risk-based review on all new chemicals, it makes a safety determination. This is critical. Not likely to present an unreasonable risk. You're allowed to use it. The next categories are problem. It may present an unreasonable risk. Well, that's, if you think of it, may basically says they now have enough data. Likely to present. So in other words, the data is very clear. And anytime you see the word unreasonable risk, it equates to EPA regulations. That's the best way of thinking this. Likely to present, the EPA again is required. There's insufficient info available. They're required to regulate. That's why it behooves you to produce accurate and available data. Again, if the new substance has substantial production exposure, they're just going to regulate. In other words, in this case, they don't even, quite frankly, the risk-based review will be quite short. And then what does business need to do based on this new environment? Well, first of all, review all your product lines now. ID which of your chemical substances are most likely to be high priority targets. Begin reviewing all available data on the results and effects relative to the environment, health, safety of those substances. Do some future planning in terms of this products. Are they going to be used? What are their current uses? What are some foreseeable uses? And you have to fully assess all current and foreseeable uses that can lead to exposures to workers, consumers, to general population, as we mentioned earlier, susceptible subpopulations. It's sometimes very difficult because this is now you're in the area of product design or process design in the sense of understanding foreseeable uses. But you're going to have to do a little bit of homework on this. And maybe look at worst case. In other words, if a substance is used in maintenance as an example, look at the worst case exposure that could possibly occur in that environment in doing those tasks. Provide EPA with sufficient info to support an affirmative safety determination. So be forthcoming. EPA will not make affirmative decisions without sufficient info. And again, as I mentioned earlier, insufficient info can lead to an unreasonable risk determination. Again, this data, all relevant info, exposure, storage, transport, hazards, use conditions, environmental impacts. Do your own risk assessments and present this data to the EPA. Don't wait for them to issue an order. Again, you can reduce time to market if you do this. If there's no risk assessment available, data available, EPA will conduct their own risk assessment, and they're going to use the worst case scenario, and that may not be in your best interests. So again, be proactive. The Amended TSCA allows companies to develop their own risk assessments. So this is your opportunity to generate sound evidence to support the chemical safety, discover and address any issues before the EPA discovers them. As one article said, tell your chemical story. This will reduce your time to market and the potential for any additional compliance requirements and enforcement. So I included a few links that should help you get a better understanding, if you don't already, of the legislation. The first one is really good. The first link, sorry. It's basically a dashboard on TSCA within the EPA. So you can see which chemicals have been identified as the first 10 and other pieces of information that will help you. At this time, I'd like to turn it over to Gusty, who will talk about what we call the science behind risk assessment and how it differs from hazards.
Okay, Gusty.
Okay, are you going to maintain control of
No,
the webinar?
Do you want me to, or do you want me to do your slides, or do you want to do your slides?
That's fine. I can show my screen.
Okay.
Am I showing the webinar?
Slide.
You're good.
There you go. You look good.
Okay, thanks. So as Tom mentioned earlier, as a part of the EPA chemical prioritization process, the EPA is required to review chemical factors to assess a material's risk. So to begin this section of the webinar, I would like to first discuss and distinguish the differences between hazards and risks. It's important to highlight that a hazard is not the risk. People often get these two terms confused. However, they are not interchangeable. The hazard is actually the source of potential harm or adverse health effects on something or someone. So, for example, exposure to benzene might introduce the hazard of an adverse health effect such as leukemia. However, it's important to distinguish that this does not mean that the exposure to benzene will automatically lead to leukemia 100% of the time. Now, drawing from my own experience, I'll give another example, which is baby powder. Baby powder has hazards associated with it. Most of us are familiar with baby powder. It was used on us while we were babies, and we even used it on our children. But interestingly enough, inhalation of baby powder over long periods of time can actually result in serious diseases. For example, recently it was determined that talc, an ingredient used in baby powder, is actually linked to long-term health effects such as cancer in the lungs and then also ovarian cancer in women. And I know this because I actually worked for a company that produced baby powder in high quantities, and this was a factor that we needed to consider and assess. We considered putting in special ventilation system. We were also considering requiring workers to wear respirators on those production lines and also in those work areas. All in order to minimize the inhalation exposure risk. Eventually the company actually reformulated the product so that it eliminated talc altogether, so that was that, and then it was done. But that's another good example of how the hazard can be related to the risk. So all of that being said, to stress the fact that in order to determine the chance of developing an acute or chronic illness that is related to a material exposure, first you must assess the risk itself. The risk is what provides the probability or the likelihood that that person will be harmed by either the exposure or that event. This can be determined by a host of factors, which might include how much that person is exposed to the hazard, how the person was exposed, so meaning whether that exposure was a result of breathing the substance in through inhalation, through direct contact with the skin, or through ingestion, or maybe through some other way or contact with the body, or you might even need to take into account the specific conditions of the exposure or the environment in which that person was exposed in order to accurately assess the risk. So to summarize what was said on the slide, it's important to realize that the risk starts with identifying the hazard itself. Then this information is used to determine the risk of the exposure. Once these are identified, steps can be taken to eliminate or control the hazard, whether that be by adjusting the environment, applying workplace controls such as PPE, as we talked about earlier, or even developing ways to engineer that hazard out of the process completely, as with the tout case. And let me move to the next slide. It looks like let me go down here. Okay, hazards can be controlled or eliminated through risk evaluations and risk assessments. Risk evaluation includes risk management and communications. This is essentially a line of communication about operational processes, procedures, or policies that need to be communicated with stakeholders within the organization. Another key element of a risk evaluation is a risk assessment. Organizations use risk assessment to identify hazards associated with jobs or tasks. Typically in the chemical risk assessment world, since that's what we're talking about in this particular webinar, you would want to know, the level of exposure. So to determine this, you might want to know information like how much of a particular chemical you can be exposed to, how many people could be exposed to that chemical, what are the operating temperatures or environment that that chemical is used in. So information like that is valuable in making a chemical risk assessment. So the control banding approach is a risk assessment approach that we here at Chemwatch have been advising our clients to take. We promote this approach because this is the only adopted approach that has been refined for risk assessment with chemicals specifically. Control banding is ideal for chemical risk assessments because it minimizes the subjectivity in the decision-making process. So what that means is that two different people running the same risk assessment scenario should arrive to the same or similar outcomes or conclusions when using this particular method. So this is what makes this particular approach scientific. It's what makes it simple. It makes it manageable to roll out to multiple levels of your organization. Workplaces often contain chemicals that can cause harm, so control banding handles that by being action-oriented. So in other words, control banding is something that you need to do in order to minimize, substitute, or eliminate the risk entirely. The approach is also very simple to use because there are only a few steps that you need to take in order to go through the entire process and method completely. It's also very systematic and user-friendly because, again, it has been designed to be deployed in small and medium enterprises. This slide gives you a basic overview of how our risk assessment, of any risk assessment for that that matter, works. We've tried to convey in this image that any risk assessment includes certain elements, and in this case we represented this by stages 1, 2, 3, and 4. It's important to note that risk assessments are performed using a calculation that assesses the hazard severity and its probability. So that is the probability that the event will happen. So let's go ahead and discuss stage 1, which is the severity of the hazard in more detail. Severity is derived from identifying the hazard and also its hazard grouping. The hazard can be readily identified from the chemicals SDS. So, for example, you can easily classify the hazard using the codes provided in Section 2. So what this means is that you don't actually have to do the test to determine the type and the concentration ranges for the chemical. All the heavy lifting has already been done by the experts, the product has already been classified, and H codes have already been assigned to the chemical. So this makes it really easy for someone to assign the chemical with a health hazard level and a group which grades it on inhalation, skin, eye, or high hazard potential. So this is actually represented by the hazard group column in the upper right hand, in the image in the upper right hand corner. So as you can see, by reading the SDS, you can easily get information that you need in order to calculate the control band for a particular chemical. Now, if you decide that you want to set up a process yourself in-house, you could refer back to the published control banding guideline in order to accomplish that goal. Alternatively, with the Chemwatch risk assessment tool, we have done the work for you. So we're able to automatically extract information from the SDS for you, and essentially what this does is it streamlines that process so that you end up with a finished hazard assessment with very little work required. In order to assess the probability of using the control banding method, first you must consider the scale of use, which takes into account the quantity used. As you can see, this translates into grams, kilograms, and tons for solid materials, and milliliters, liters, and cubic meters for solids. It's important to know because, this is actually important to know because with control banding, there are different rules used depending on whether you are using a solid or a liquid. So that's important to keep in mind. In addition to scale of use, in order to accurately assess the probability, one also needs to take into account the substance ability to become airborne. This is also very different for solids and liquids. So for solid, this refers to materials that specifically break up into dust-like particles, and for liquid, it refers to the substance's volatility. So this is the substance's ability to evaporate and disseminate or disperse into the surrounding air. So as you can see, these are graded into high, medium, and low categories. The grade type is largely determined by the substance physical form. In the case of solids, so let's go back here so you can actually put this with an image. For the case of solids, you will see that, that solids are determined by their physical form, and for the case of liquids, this is largely determined by the substance's boiling point. So you can see that this is also determined by the substance's operating temperature. The graph on the right illustrates the relationship between those two and how you can band the substance into 3 different volatility categories. So the last stage in the process is the risk calculation. So once you've determined the severity and probability, you are then able to determine the risk by using a matrix. This this matrix is what gives you the overall risk of the substance. You can perform these calculations manually, or you can actually have our system calculate those for you. As you can see in the screenshot below, parameters are defined in the middle columns. So this is where you would specify, the operating temperature, the volatility or dustiness, the frequency use, and then once those are defined, our system is able to determine a hazard rating. And this also has a risk associated with it, so it automatically calculates that for you. Additionally, our system uses risk matrices to allow risk bands to chemicals as well. So this will predict applied controls, and so that's illustrated in the picture in the lower right-hand corner. Risk matrices are commonly used in industry to assess risk levels. You might even be using these currently to assess different things in your company. I know we had these integrated into our JHS or our JHA or JSA forms at the manufacturing facility that I used to work for in the past. But regardless, typically these are developed in-house, and they're based on your organization's specific needs. During our demonstration portion of the webinar, where we show you our Chemwatch risk assessment module, Nora will actually show you a little bit about how this matrix can be created and customized to your specific needs. We provide 5 basic levels in our default setup, but you can have as many as you would like. You can adjust these levels in our system setup, so just keep that in mind. By determining the risk, you are also able to use the control approach. So if the risk is low, you might have to do, basic things like training or implement good housekeeping practices. However, if the risk is high, you will need to implement appropriate controls. So the International Labor Organization has actually developed a toolkit that identifies different control approaches that you can take, and these approaches are summarized in task-specific control guidance sheets. These control documents address how to control exposures related to inhalation, skin absorption, those that are related to the environment in which the worker resides. It also covers safe handling controls, and then also general maintenance control guidance. Additionally, they also have checklists that you can use within your workplace. So these documents they give specific information on what to do given a particular scenario. All of these documents are available through our Chemwatch interface, so these are really useful if you have time to look through them. Lastly, if you would like to take your control approach to the next level or one step further, you have the opportunity to design and implement engineering and administrative controls that would essentially just mitigate risks down the road. Our software solution allows you to define and design and you can design construction and segregation controls for a specific task. So as you can see an example of that on the image on the right. But Nora will actually showcase some of this in her demonstration, and that being said, I'm going to go ahead and pass the baton to Nora so that she can show you how to streamline your risk assessment process using our tool. So I'm going to go ahead and do that now.
All right. Hello, everybody. My name is Nora Ballant, and I'm going to give a demonstration of our risk assessment tool. So I hope you can see my screen. This is our risk assessment module of Chemwatch. If you've seen Chemwatch before, you've seen that we've demonstrated primarily from the home module before, where you can search for SCSs and do some SCS management there. But now we're going to take that one step further to do the risk assessment tool. So this is what the main screen of our risk assessment tool looks like. I have stored some materials in one of my folders. This is a small folder. I only have about 9 materials stored here in this folder. But this risk assessment tool will give you an overview of what I have here and what different controls we have in place. So as my colleagues have described, the risk assessment, the purpose of the risk assessment is to identify the hazards of the material, tell the system how you're going to use that material, and let the system determine that based on the hazards of the material and the controls that you have in place to mitigate that risk, what is the risk band, the risk for using this chemical in this environment. And so we're going to go through how to do that here today. So you can see right away I have 9 materials here, and you can see in this column here the hazard rating for those chemicals. So the core of our product are these SDSs that we have. We have several types of SDSs in our system. We have gold SDSs. Those are the ones that are written by our chemists, toxicologists, hygienists that we have on staff at Chemwatch. And those, we have identified the risk of those, the hazard level for those chemicals. That data is then available here in this column. We also have vendor sheets available. These are the SDSs that you get straight from a vendor. We store those as PDFs in our system, but for many of those, we extract that vendor data for you. So you can see that we have a gold document here with the AU symbol, and we have a document with vendor extracted data here. So we can pull that hazard information either from a gold SDS that our chemists have written, or we can pull it from the vendor extracted data. If we have a vendor sheet for it and have pulled out that data, then we can use that data to do our risk assessment. And then we have documents in our system, such as this one here. You can see it has a question mark here in the hazard rating. And this means that on this particular one, all we have is a vendor sheet, but you can still extract data for that to use in your risk assessment. So you could click here to check that vendor sheet and extract the data yourself so that you could then proceed with your risk assessment. But for now, I'm going to go ahead and do one where we have a gold sheet available. We also have vendor extracted data. So we have all of the hazard information available that we would need to do our risk assessment. So I'm going to use acetone. To begin a risk assessment, you're going to first want to assign a task to that product. So we're going to say that we're using acetone in this case for mixing, which is just a generic use, but we have a lot of other specific uses identified here that you could assign a task to. So maybe you would use it for infrequent charging reactors. It wouldn't be appropriate for acetone necessarily, but there are lots of different tasks you could assign here to specify how you're using a particular product. And if we don't have the one you need already, you can define your own task. This is primarily an administrative tool to allow you to group different chemicals and uses together in a job. And I'll get to that in just a moment. So for now, I'm just going to say that we're using acetone for mixing. You can see that the system has already identified that the hazard is a level 2, and you can hover your mouse over that 2 to see what the hazard codes are for this particular product. You can then tell the system the operating temperature that you will be using this chemical in. So right now it's set to default at 20 degrees Celsius. You can use this bar here to adjust the temperature, or you can type in the temperature that you want to use, where you want to use the chemical, and we can accommodate very high and very low ranges. All right, so I'm going to put in 38 degrees, and you can see that it's got a high volatility and dustiness. So in this case, it's a liquid, so it's going to be the volatility. And as Dusty explained, this is the likelihood that this product can evaporate quickly or slowly. So the system already knows, you can tell by this little lock key, that the system already knows the boiling point for acetone. And so it already knows that it is a high volatility. You can unlock that and change it if you wish. And acetone is kind of right on the edge of what we consider high and medium. So I'm going to leave it at high for the moment. And you can see that before I've even set many controls on this, the hazard rating is a 2, and the system considers the risk to be a 3. But I've not yet told the system all the different ways I'm going to use this product. I'm going to set those things. I'm going to leave it at high for now, high volatility. I'm going to say that my scale of use is in tons. And you can see that as soon as I did this, the risk changed to a level 4. So just increasing the quantity of scale of use increases the risk of using this chemical in that condition. I'm going to say that I use it for more than 4 hours. We're still at a 4, and that I use it daily. So with this particular list of conditions, I can look at a checklist, and the system is going to suggest different things that you should do if you're using this chemical in this situation. You should wash your hands before use. I can check that I do any number of these things. Do not use solvents to clean your skin. So I can go through and check which of these things I'm going to do in my business, in my environment. Now, one thing to notice is if I change some of these factors, some of the things even on my checklist will change, and also my controls. If I click on the controls, right now I have no controls in place, but if I click here, the system will suggest that for a level 4 risk, you need containment. If I check off containment, immediately the risk goes down because I have indicated that I'm going to put that level of control on my product. I'm going to close that for now, and I'm going to change a few of these parameters. I'm going to go back to 20 degrees Celsius. So the system then automatically changed it to a medium volatility because of the temperature. So it was a high while it was a higher temperature and more likely to evaporate more quickly. Now that I've lowered the temperature, it brings it down to a medium volatility. I'm going to say that we actually use this in milliliters, and as I do this, you can see the risk is changing as I make changes here on the left. So using it at this temperature with milliliters already takes it down to a level 0, although I do have controls in place as well. So I'll make a few changes over here as well. And you should see the number of checklist items also go down. So the system is dynamically determining what controls you should put in place to minimize the risk in this situation. I'm going to click back on controls again. In this case, you can see in green that the system recommends general ventilation is all you need to mitigate the risk in this situation. I'd still have containment check. You can define as high a level of control as you wish, as is appropriate, and you can even define your own. So let's say that in addition to general ventilation, I want to say use this product outdoors. And I'm going to say that that's a level 2 control by right-clicking on a level 2 control and adding it. So I can turn that level of control on as well. You can edit that or delete that if you wish. You can also review the personal protective equipment that's recommended. Chemwatch is automatically going to suggest certain personal protective equipment for any particular product, and you can see those have the little check marks here up above each of the recommended personal protective equipment. So I can turn any of these on or off as I wish, and when I'm done I can submit it. It's going to save that, and then these personal protective equipment that I chose will show up on my risk assessment report in just a moment. I can also say that training is required if necessary. I can then tell the system how I'm going to discharge of this material once I'm done using it. So in this case, I'm going to choose water as my discharge, and I am going to save my report. You save it by just clicking lock, and it's going to ask you, are you done with your risk assessment? I'm going to say, yes, I am. And I'm going to say no to that. What that meant, although I could have said yes, either one is fine, what that message meant, it said, do you want to copy data over to other nodes? We have 2 different nodes that we're working with. You can see those tabs here. We have the International Labor Organization. This is dealing with the health effects of a chemical. And so most of these, well, all these controls that you're looking at now are based on the ILO model of health effects of these chemicals. But we also have a United Nations dangerous goods classification. What that one little pop-up meant is, do you want to copy over all of the controls you just set, all of the data you just set for acetone into the UN mode as well as the ILO mode? I'm going to go back to ILO for now. I'll show you both, but for the moment I'm going to go back to the one we were working with so I can show you just a few more features. I have saved our risk assessment. I've said that I'm done. Now the system has automatically generated some control documents based on the control measures I put in place, based on the tasks that I'm using this for. For example, If I look at the guidance sheet, I believe it's going to be 318 is one that I wanted to show. This shows a guidance sheet for mixing liquids. So I said that I'm using this for a mixing task, so the system automatically pulled in a control approach for mixing liquids, and it'll give you some guidelines on how to use that in a safe way. There are several other different types of control sheets here that are available based on the things that I chose. Respiratory protection document. So this one is based on the COSH model. And then you can add your own, so that we have a user-defined tab here, so that if you have your own control documents that apply in your workplace, you could add those here. You can add a link to your own document. And I'll close that out. When you're done with your risk assessment, you can generate a report. I'm going to say that's complete again. You click on this button that says report, and what it's going to do is it's going to bring up a document that shows the hazard of the chemical, and based on all the controls we've adopted, we've brought the risk down to the minimum amount. And it's going to then go through this document and tell what controls we've adopted. We've told the user to use this product outdoors, and we've applied containment. We've applied a respiratory protection factor of 4. One of the things you'll see here, it'll list the ingredient that we have been assessing, and it'll tell the occupational exposure limits. Now, it's going to show the occupational exposure limits for the default jurisdiction. So my system is set to United States English, so it's going to show the document in English, and it's going to show the United States occupational exposure limits for this product. It'll show the hazard ratings down here. So these are the hazard ratings that were reflected on that first page when I said that our system has already identified these hazards, and then we're going to apply the controls. It'll give you the personal protective equipment summary. You can scroll down. This checklist here, these are those green buttons. When I had the list of all of the things in a checklist about controls we could put in place, it's going to list on the document every one that I checked. I think I only checked 4, but there were lots of them available. So as many as I checked will show here. It'll give the precautionary statements, the hazard statements. You'll see it's not giving hazard codes and precautionary codes. It's just giving the statement. This makes it easier to read so that you don't have to memorize what every code means, what every H code means, but it'll give you the statement about what that does mean. Now, if you scroll down to the bottom of the document, you have a place that you could send this through an approvals process. And the way you would do that is you would simply click on approvals here at the top. You can give it a job code, and you can give it a job name. Now, as I do that, the system is going to look through jobs that I've already defined. I only happen to have one in this system at this moment. So I'll assign this task of mixing acetone to the job of oil removal. I'll say it's assessed by Nora Ballant. If you have a signature on file, you could select that from your computer and add a signature to this document, an electronic signature, and you could say who is now approved by. I'm going to put my colleague in there, Gusty. Here you would say the number of people who are exposed to this. So I'm going to say 25 people are exposed, and then you can define an operating procedure if necessary. And give a review date, so how long before this assessment needs to be reviewed again, and then you submit that. When you do, it's going to fill back in that report with all the information it had before, and then it's going to add those fields here at the bottom of the page. You can then save this report to your computer, or you can email it to someone if necessary, and you can change it into 47 languages. It's going to apply the jurisdiction that you've chosen, the default jurisdiction for these, as you change the language. All right, let me pull back a little bit and tell you, I'm going to show you briefly about the UN controls that you can put in place. Again, this is going to be more about the dangerous goods and the transportation of the chemicals, but it works the same way. You simply unlock your risk assessment, you go and put the conditions of use, and then you can apply controls. These controls look a little different, but it's the same idea. You tell the system that you've considered the flammability of the chemical, the explosion possibilities, and then you can put in different controls in place. So in this particular case, I'm choosing engineering controls, so you can consider ignition sources. You can consider a firewall, doors and doorways, how you're going to address those controls, and check off whichever ones apply. All right, let me pull that out. And now let me go show you how the jobs work. As you saw, I did an assessment on a chemical, and then I assigned it during that approvals process to a particular job. So now I can pull out, excuse me, I clicked on that. I can pull out that particular job with all of the tasks that are involved in that job and pull a job report to show how those would, how the different protections would be recommended. So let me pull that up for you. So I now have oil removal and I have mixing as my task. And so I can click on that and show the different products that are assigned in the mixing task. I click on oil removal, I can pull up a job report, and it's going to give you some of the details that are involved there. What the controls are, what controls we've applied, what personal protective equipment is recommended, what controls we've already applied. And so you can pull off a job report to give you the hazard and the protections that are involved in that job. All right, so that is a basic overview of that system. Let me hand the presentation back to one of my colleagues, Tom, Paul, who would like it.
Thanks, Nora. That was great. So you should be able to see my screen now. And Tom, do you want to fast forward through these, or just tell me what you want me to do?
I'll go through them, and folks, we have 10 minutes. We want to spend at least 5 minutes on Q&A. So what I want to touch on quickly what you just saw there and just highlight a couple key points. First of all, the ILO model is actually based on a 40-hour work week. We've changed it. We've adopted a model produced by scientists at Lawrence Livermore around nanomaterials that allows you to look at shorter durations and frequency of use. So you can break this, you can get this data very granular. Go ahead, Paul. Also, this is task-specific controls, what Nora was showing you, and that is following. If you have a worker that's handling a substance with 5 or 6 tasks in a work cell, but only one of them is deemed to need containment, what we can, with this, you can isolate, lack of better terms, the specific user controls and also the specific design, construction, and segregation controls specific to a task. So basically, you wouldn't have to provide, let's say, containment for a number of tasks, just possibly a specific task, and it allows some flexibility in your process design. So again, what we're talking about here is a job is a series of tasks, and that's how we look at it, and that's why the data is very granular, is that we do it on a task-by-task basis. It allows you, quite frankly, to summarize these tasks specific to a work cell activity, use the worst case as an example of how you may want to look at the entire work cell. Or again, as I mentioned earlier, you can just specify a specific task that is the worst case and provide a control specific to that, and the rest you would just provide, let's say, the default controls, possibly just ventilation. And what I had mentioned earlier on the control banners for the worker, and again, these controls again are very specific to a task, but again, specific to a task around the storage and transport of the material. Again, you can provide engineering, administrative, or any type of control around a specific task and not the entire work cell. From a facilities engineering point of view, this is very important and can save you a lot of money, especially in an industrial environment. And as Nora was mentioning, the key is the risk assessment report. It's a key document for your EPA reporting requirements. So you can basically create a set of risk assessments. Let's say you can look at your entire collection of chemicals, and for instance, our software allows you to do hazard filtering on the entire set and identify, let's say, all chemicals that are corrosives, or all that are embryotoxic, or all that are carcinogenic. And based upon those, then you can do specific risk assessments on those chemicals. So this document, let's say, centers around a lot of other hazard analysis and communication. And again, why us? Well, the risk assessment, like all our chemical management modules, SDS management, inventory management, sits on top of a unified model of data, of our chemical scientists, as Paul mentioned, and also our platform. We haven't talked much about that, but being a SaaS platform, we host and manage all the data. But it allows us to provide a seamless platform where the applications can tap into the, we'll call it the pool of data, seamlessly and quite frankly with a click of a mouse. And what that basically means, you can go for inventory analysis, as I just mentioned, right to a risk assessment, all with literally just a few clicks of a mouse, acting on the same pile of data. And we'll call it the risk assessment module specifically, but all our applications access our core business. Again, our expertise, 170 out of 250 employees are chemical scientists. The data, we manage that on your behalf on a platform that we host and manage and that's fully scalable. And this basically allows you to achieve compliance, whether it be TSCA or any other type of compliance, easily and effectively with the latest data in a seamless fashion. And basically what we call it future-proofs your business, allows your business to be scalable and grow its chemical management capabilities accordingly. And Paul, it's your turn.
I was going to say, Tom, that was great. I was a little concerned we were going to run out of time, but it worked out just perfect. We knew we had a lot to cover today, and we just wanted to make sure that we were able to get through everything and do have some time for some question and answer. And I see one question that kind of popped up, and it was, you know, your demonstration seems to focus on pure substances. Will this work on mixing products as well? And the unified model that Tom had the slide up, we didn't actually go into our authoring engine, but you actually can use a piece of our authoring engine that allows you to do exactly that, to take your chemicals, put them into our what we call Credo engine, and then run a risk assessment. So anyway, Nora, do you have some questions? Nora's wearing two hats today, demonstrating and kind of watching the question and answer board. So Nora, would you do
Yes, I could. In fact, I was just in the middle of answering one as you said that, but I'll go ahead and address a few that I have here, and then those that we haven't gotten to. We do have a lot of questions, and so we've been able to get to a few of them privately. We will get to the rest of them after the webinar and send them out to everyone. But I do have a couple that I thought would apply to everyone. One of the questions is, how do you manage effective communication for chemical risk assessment when a work party is using multiple products simultaneously? For example, epoxy materials, part A and B, multiple solvents, grouts, and powders. Are 6 individual risk assessments practical and effective? So you would have to do an individual risk assessment for each one. And the answer is that, yeah, in our approach, multiple products and tasks can be grouped together under jobs, like I showed you, where you can click on the job and you can have multiple products and tasks. It can be a little time consuming to do each one individually, but it's worth the work because chemical characteristics can vary quite significantly. That if you don't assess each one individually, there may be some things that you don't know about the chemical that would have been important to know. So it can be time consuming, but it's important, and then you can group those together in a job and get a report of what that job's hazards really are. And then another one said, will the risk assessment change if I'm using the vendor SDS as the source of the hazard information rather than the Chemwatch gold sheet? And that's a really good question. We do have both of those available. And so basically Chemwatch will do an independent review of a product. If we have done if we've done a review of that same chemical and our classifications are the same as the ones that the vendor has come up with, then the assessment would not change. If we've come up with the same hazards, then those same hazards would apply. However, if we've done our own review and we have determined that the hazards might be different than what the vendor has assessed, then yeah, the risk assessment would change a little bit based on that. But we do frequently agree with the vendors. It's fairly standardized. You will find even vendors disagree somewhat with each other on exactly what the hazards are that would apply, and that's sometimes true when we've reviewed one as well. We do tend to take a conservative approach to safety since our primary goal is information, hazard communication, and worker safety. So we do sometimes take a little bit more conservative view of hazards than some vendors do. And then do we have time for one more? I have one more, but
I think
if
so.
we don't, we can just answer them all offline. One more? All right.
I was going to say, why don't you do one more?
So
and then, yeah.
Okay. All right. So the last one is, does the Chemwatch risk assessment process assess a combination of chemicals when undertaking lab experiments? So that's a good question, and there are two different aspects there. One aspect of that risk assessment evaluation is predicting the reaction and assessing the final combination of chemicals. So reaction predictions are not something that we do by default, but what we do is we do have a tool where you can put in your mixture. This is what Paul was talking about before, where if you made your own mixture, we have this authoring Credo tool where you can put in the ingredients in your mixture. The system will somewhat predict what the hazards might be, but then you can change those based on what you know about the chemical. And then based on the hazards that you determine, and this is if you're writing your own, of course, based on the hazards that you determine, you could then do your risk assessment based on those hazards. Now, if Chemwatch has already written the SDS, or if we have the vendor data for that, then we'll be taking the hazards off of that sheet. But if you're writing your own, when you've combined your own mixtures of chemicals, you would want to use that mixture authoring tool and then use the hazards that, that you've indicated when you did that authoring piece.
Well, that was great, Nora. Lastly, we are having another webinar on April 20th, and this will be around the topic of WMIS 2015 and then how that affects your labels, SDSs, and information. So be sure to look for that. And any question that you ask that we didn't get back to, we will send you an email on that. And you know, we hope to see you at our next monthly webinar. And that being said, it's 12 o'clock, and I think we'll go ahead and wind this one up. We do appreciate you joining us today. We hope you found it informative, and please look for our email that'll have a link to the recording as well as a PDF with the PowerPoint. Thank you so much for joining us, and hope you all have a good day.